Students, my name is Sumit Mehta. So today we are starting a new chapter named as continuity and differentiability. Okay, so first we will discuss about what is a continuous function. Okay, continuous function. Students, here I am supposing that you have studied well about the limits in class 11th. Okay, so we will discuss on limits about the continuity of the function. Okay, so here is the definition. Suppose f is a function real function on a subset of the real numbers and let C be a point in the domain of f. F is function here, then you can say that f is continuous at C if limit x tends to C fx is equals to f of C. Means, student, if there is a function which is defined at all the values in its domain. Okay, so the function is said to be continuous in its domain. Okay, let me give you one example on that. Example is, examine whether the function f given by fx is equals to x square is is continuous at x equals 0. So student, in this question we need to check whether the function fx equal x square is continuous at this or not. We can solve this question either by limits, or if you know the graph of this function, then you can clearly state that whether the function is continuous or not. Okay, so without going into the graph of the function, let me check whether the limit of the function at x equal to 0 exists or not. Okay, so I'll check the left hand limit and right hand limit as we were doing in the limits chapter. So first I am checking about right hand limit. So this is h tends to 0, 0 plus h square, which is h square, limit h tends to 0, this is 0. Now left hand limit h tends to 0 minus fx is equals to limit h tends to 0, 0 minus h is limit h tends to 0 minus h whole square, which is again 0. So hence we can say that as left hand limit LHL is equals to RHL, left hand limit is equals to right hand limit, then we can say that function is fx equal h square is continuous at x equal 0. Okay, student, let me take one more example on this. So students, here I am taking one another example based on to check whether the function is continuous in the defined domain or not. Okay, so I am writing down the question here, which is define the continuity of the function f defined by. So this is one of the typical question, students, in which the range or the function is split in two parts. Function is defined as x plus 2 when x is less than 1, or x minus 2 when x is greater than 1. So we need to check the whether is function is continuous or not. Okay. So student, to do this type of questions, as we know, this function represents a straight line as it is a linear polynomial in a straight line. Okay, means it is like y equal x plus 2. So this line represents a straight line, and this line also represents a straight line, but the doubt here is at point x equal to 1 whether the function is continuous or not, because except 1 at all other the points the function is continuous. So we need to check whether the function is also continuous at x equal to 1 or not. So how we will check that? Let me draw the graph also of this function, then you can easily state that. But we will also check by using the limit. Okay, so y is equals to x plus 2. The at x equal to 0 the function is 2. This is 0 comma 2. So the function behaves like this, because the y-intercept here is 2, and y is equals to x minus 2 lines is again parallel to this and going through 0 minus 2. Okay, so these are the two lines, and we need to check the limit at this is 1 comma 3, and at x equal to 1 1 minus 1, and this is not a student here, this is open bracket because it is not equals to 1 here. Okay, so the function will start from only this function, and this function is defined below 1. So I cannot plot the function above 1 here, and below 1 here I cannot draw the function. Okay, so I need to check whether the limit exists at 1 equal at 1 or not. Okay, so we will check if in case wise, if c is less than 1, this is the case 1, student, so fc will be c plus 2. Okay, so therefore the limit x tends to c, fx is equals to limit x tends to c x plus 2, which is also c plus 2. So therefore the function is continuous at all the points less than 1, as you can also see that from the graph. Okay, now I am directly jumping into the region where x is equals to 1. Okay, if c is 1, then left hand limit is fx, limit x tends to x1 minus is equals to limit h tends to 0, f of 1 minus h is, this is 1 minus h plus 2, this is 3 minus h, so this is 3, and limit x tends to 1 plus means right hand limit h tends to 0, f of 1 plus h is 1 plus h. So it is defined here as x minus 2. So the here is limit is h minus 1, which is minus 1. So you can clearly see that both the limits are left hand limit is not equals to right hand limit. Okay, so in that case limit does not exist at x equal to 1. So we cannot say that the function is continuous at x equal to 1. So you can clearly say fx at x equal 1 not continuous. Okay, so students, now I hope that you can check the continuity of the function at any point very easily, and in the next lecture student we will discuss some properties and some algebra of continuous function in next class. Okay, so stay tuned for that class. Thank you students, happy learning.